Gymnotiform is a South American order of freshwater fishes, suggested to be most closely related to Siluriformes, which are the catfishes. They are often referred to as knifefishes for their unusual body shape. The issue with this common name is it is applied to some species in the distant suborder Notopteridae, which is exclusive to Africa. Notopteridae also contains the knifefishes, which is Memoridae, and some rather strange looking fishes, much like Gymnotiformes in appearance. These fishes can be easily identified from their knife-like shape, an undulating anal fin stretching across the ventral side, the bottom of the fish, and the only other fins would be the pectoral fins, and perhaps in two of the groups within Gymnotiformes, such as Electrophorus, they will have a caudal fin, which is the tail fin. The anus also tends to be shifted towards the anterior of the fish, so can be right below the head almost. There's a variety of body shapes, head shapes. Some species display an elongated head and others a rather short, stumpy head. What makes this family special or interesting is their electrosensitivity, which they use to communicate, generating electrical signals, but also to locate food. And for Electrophorus, which is the electric eels, they are knifefish, they are not eels, in the sort of sense of they're not actually anguilliform, which is the true eels. But they can generate an electric shock using this electrosensitivity, producing electric waves. Strangely, Memoridae also display this electrosensitivity, along with two other Notopteridae, Xenomystus nigari, which is the African knifefish, and Gymnotiformes niloticus, which is the abba knifefish. So these are placed within a entirely different group to Gymnotiformes. You would think they'd have some relation to Gymnotiformes, but in reality they are placed in a much more primitive group of teleost fish. Teleost are a lot of the fish we deal with will be placed in or are teleost fish, and teleostia I think is the name, or pronunciation is a bit more. They're actually in Osteoglossiformes. So Memoridae is an Osteoglossiform, and as are the Xenomystus nigari, Gymnotiformes niloticus, and they are not Gymnotiformes. Osteoglossiform also contains the arowana, such as Scleropages formosus, and also the butterfly fish. They are known often as bony tongues, that particular group. So what's happening here? Morphology can infer phylogenetic history of a species. Closely related species are likely to show, and closely related species taxa are more likely to show a similar but also different morphology. So you'd assume the more closely related you are, the more similar the morphology is. And this is part of why we use morphological phylogenetics to build a family tree. But it's important to recognise what is phylogenetic and what is evolved, what morphology is evolved for a niche, a function, what morphology is functional. And of course, functional can be related to the phylogenetics as well, because similar taxa might exploit a similar niche, a similar diet, maybe they prefer a similar habitat. But it does vary, and it's important to recognise that there's two different sort of aspects to this. So it can infer shared aspects to a niche, but no species will exist where there isn't competition as well. So there will be differences between taxa, and you can assume that the differences sort of build up a sort of distance between different taxa, different groups. Species are evolved for their habitat, ecosystem and functional niche. Large eyes for dark habitat where vision might be important. Although losing the eyes and relying on other senses might make a good trade-off in maybe sort of cave habitats or even very, very dark habitats. It depends on the senses. You might see catfishes with very reduced eyes, and maybe they're using taste, which catfishes have amazing ability for. And also we see this in knifefishes. Gymnotiformes have very small eyes. They're depending very much on this electrosensitivity to see the world around them. Although Xenomystis nigari has very large cat-like eyes. And we can see it all across the animal kingdom that large eyes can be used in the dark, but also reducing those eyes because eyes are costly. They're very costly to produce, and if you're not going to be able to use them, and it just, because you have to eat and drink and stuff like that, and that some of that energy from that is going to have to build those eyes and also maintain those eyes. Eventually facing mouth or feeding at the bottom makes sense. Rasping toothpaste for ulfruch, which is like algae, stuff that you really have to sort of dig at, almost thinking like moss on a stone. You're not going to be very good if you're just using like prongs, which is why the longer, fewer teeth for invertebrates and being able to manipulate the food. So these are evolved over time. There is no a sort of end purpose. It's just what happens to be successful is what that will become more frequent in a population, whether it's having a longer tail, a shorter tail, no tail at all. If it's a climbing species and a prehensile, a moving, grasping tail is good, then that's going to be more common in the population than one without a tail that might have issues of balance. So also predators might have terminally facing mouths right at the end of their head or dorsally facing, depending where they're feeding. If you're feeding from above you or in front of you, which most predators will do, you're going to want a mouth in that placement. Fast flow can result in a real advantage for flat appearance. It's energetically costly to be resisting against a water current that you're going to have to swim against or even just sit there against. So it makes sense to have that dorsally, ventrally flattened body, whereas deeper bodies might make sense or be like neutral in a habitat that isn't has a lower flow. So say discus and stuff like that will benefit from not having, well, they wouldn't have that trait, wouldn't have a benefit, so that it probably wouldn't actually become sort of very common in the population, if you get what I mean. So this is a system of reducing costs, energetic costs, maintaining, developing organs and tissues, adapting for an environment and avoiding predators. It's not just about predators though, it is about competition. You will have species competing or having similar niches. You're never going to have the same niche or exactly the same, because then they're just going to outcompete each other. It's all about sort of battling between having enough food and being able to reproduce and also surviving. Gymnotiformes and Memoridae though, and more specifically Notopteridae, have evolved such morphologies to allow them to predate and communicate effectively using that electrosensitivity that they share. Hence they will have developed that very similar morphology. And you can see that with Gymnotiformes, which are the spiny eels and swamp eels, and also comparing them to Anguilliformes, which is your true eels, like Anguilla, there is one I can think of, but not right now, of a true eel, or like moray eels, like. So they will share a lot of, if they're going to share a niche, they're going to share similar morphologies, because those are the successful morphologies. Dolphins, sharks, ichthyosaurs all have a very similar morphology because it's aimed at a similar niche. They're all large, mostly sort of typical sharks anyway, pelagic, predators. So they will share those similar appearances. Or maybe dolphins might be a better one. Oh, dolphins anyway, comparing to ichthyosaurs, share probably more similar than most sharks. So even though they are distantly related, it doesn't really make as much of a difference. So the morphology allows them to hover, particularly in Gymnotiformes, and that helps them with locating food with minimal movement disturbance. And it just allows them to focus on sort of building that sort of, what would it be, electric field that they can identify the food. They're usually small eyes in these taxa, eyes being costly. They don't need it. They're using their electrosensitivity. The exception maybe being, so you know, Mr. Snigari, which is the Notopteridae, which has large reflective cat-like eyes. And they probably are using both. They're not as electrosensitive as Gymnotiformes and Memoridae, but they have some ability to do it. A lot of these species have small mouths, and that aims in feeding on small invertebrates. Larger mouths are obviously for the ambush, and those feed on larger items because it makes sense to have a mouth larger than your prey, but you don't want something so large that you're going to sort of not going to be able to narrow down to it properly. A longer snout is found, especially like Gnathostomus petersi, the Peter's elephant nose. Also many Gymnotiformes, you don't really see them in the trade so much, but they will have longer mouths. They're looking through silt, through leaf litter, through a substrate or something to look for food, a bit like anteaters in a way, because they're sort of going down into something for that food. And it also, I would say, reduces the resistance. If you're going down in something, you don't want a wide block going down into a block of a mouth. You want something a bit more narrow so you can sort of target your food better. Of course, coloration as well. A lot of them are darker. They're found in dark habitats. It makes sense. You do get the very beautiful appearances in Gymnotus. Perhaps that sort of breaks up their outline. These are fish that they will, Gymnotiformes and Memoridae, all of them, they hide a lot. But it's other sort of adaptations to be able to hide, to break up your outline, which is really important. Most of them are just that dark appearance. Gymnotiformes, actually, it's quite interesting. They do have the ability to colour morph, a bit like Lorcaridae. But it seems like when they're found in darker habitats, they can have the ability, and I've seen it myself, to lose pigmentation when in the dark. And you'll find that in Panax, such as Panax bathyphyllus, can be found completely white when it's brought up to the surface. And these fish live in deep water. They're white almost. They don't need colour, but then they will regain their colour once they're at the surface. But I've seen it with Gymnotiformes. I've not seen it with Memoridae or any of those. Although these shared traits do not infer a relationship between the groups, just shared niches, they share a similar evolutionary path. Not evolutionary path, it'd be sort of an evolution towards a shared niche would be a better way of explaining it. Instead of other features might infer phylogenetic relationships between members of the same taxa, Gymnotiformes all share that anguilliform eel-like appearance, lacking a dorsal fin, ventral fin, adipose fins, but which you do see the dorsal fins and the other fins in Notopteridae. Only a few taxa within Gymnotiformes have that caudal fin. Whether it has been lost and re-evolved, or they always had it and the others lost it, is another argument in itself between sort of has this trait evolved multiple times or has it been lost a number of times. And sort of that's when you think a lot of parsimony. So it makes more sense that if only two of those taxa, unless they're both basal, like both, that they probably regained it. It wasn't so, or maybe that whole sort of element in the genetics, the genes, weren't entirely sort of lost. So it wouldn't take much to re-evolve it, I guess, is the best way of explaining it. The anal fin in all Gymnotiformes extends the whole way along the body, and the anus is displaced anteriorly. So the only knifefish that isn't a Gymnotiform, the only not true knife that really is difficult to define, is the Xenomystis nigari. Well, one of the defining features of Gymnotiform knives, the true knives, is that their eyes are reduced, which is Xenomystis nigari has massive eyes. So it's quite easy to separate them. They do look very distinct. So there's one sort of well-known knife I haven't mentioned, and that's the clown knifefish, Chilata, which is actually a Notopteridae. It has no electrosensitive ability. The appearance matches more of an ambush predator that isn't, and it's got a large mouth. They're extremely predatory. They're monster fish that I think that people look for knifefishes because they have this electrosensitive ability. And even with a quick Google search, you can find that the clownfishes do not have that ability. So maybe it's half the appearance people are after. Afro knives are in the same boat. I don't think they have any electrosensitivity either. They all grow insanely large. Not that Memoridae and obviously Gymnotiformes have members that aren't extremely large. Electrophorus is gigantic in the first place. Other knives can get like 50 centimeters, 60 centimeters in I don't remember the scientific name, but Memoridae, then elephant noses, which aren't really going to be mostly called knives. It's more the sort of groups outside of Memoridae. They have some gigantic species. They're just neither particularly common. They don't tend to do too well in captivity. It's these very generalists, I guess, that don't rely entirely on electrosensitivity that do well. Or they're happy to feed, well, mainly if they're happy to feed on dry food and not extremely selective. A lot of Gymnotiformes and Memoridae are extremely selective, especially those that want very small food. They're a nightmare in captivity because they want certain food. And sociality varies so much in these groups. Xenomystis nigari is shoaling. Many Gymnotiformes are, but you also get territorial ones like Gymnotus. They won't tolerate each other at all. So this is sort of a lesson in convergent evolution. Some species and taxa evolve to a shared niche, I guess, and they might look similar. It might not even be a shared niche, but what's required for those niches makes them look similar. So what defines... So the other one, eels. What defines an eel? Because there's so many different groups get called eels. Symbranchiformes being the main one. But in general, we should be careful with common names, and they can create so much confusion. Anyway, thank you for watching. And if you like my videos, please subscribe, comment, like, and thank you.